Okay, so I think we will go ahead and get started. I just want to welcome everybody here today. We're very excited to have you and to have our two presenters. So I'll just say a little bit about Holly Lynn and Peter, and then we'll go into the presentation, and then there'll be hopefully some solid time for conversation and questions at the end of this. So you are at the NCDS DataBytes Lunchtime Webinar Series, and today's speakers are Dr. Holly Lynn Lee and Peter Baumgartner. Holly Lynn has been at NC State since 2000. Her research interests include teaching and learning of probability, statistics, and data science, especially incorporating technology use and designing technology environments that facilitate student learning. She situates her work in educational design in order to provide the best learning opportunities for students in K-12, her university students, and educators around the world that engage with her in online professional development. We are very happy to have you, Holly Lynn. And then Peter is at RTI International Center for Data Science, where he combines design thinking and modern data science to discover data-driven solutions. His work spans the domains of criminal justice, law enforcement, public health, agriculture, and sociology. Peter's technical focus is natural language processing. He is the founder and project lead of RTI TAP, a text analytics platform that uses natural language processing and data visualization. And we are also very happy to have you on board today, Peter. So for the audience, you probably know why you're here, which is today's talk titled Bringing Data Science to Middle and High School Education. The talk will be about 35 to 45 minutes. There's specific time for question and answer at the end. However, Holly Lynn and Peter have said that if you have sort of relevant comments that are kind of quick to what they're talking about at the time, or quick questions, you can send a chat or raise your hand and I will unmute you, and you can, kind of join the conversation as it's happening. If your question's longer, or you kind of want to spark some discussion around a topic that they've brought up, if you just type your question in the chat window throughout, we'll hold them until the end, and then we'll have sort of a longer discussion at that point. So I will stop talking now, and you guys can take over. So welcome, Holly Lynn and Peter.
All right, great, thank you. So Peter and I's collaboration really took off this year, this academic year, since August, when I was awarded a university scholar position at RTI University, where they are essentially buying out about half of my time to spend in collaboration with the good folks at RTI. But we had started conversations several years ago, and it's just really nice for us to finally have the time and energy to dedicate to this collaboration this year. So let me share my screen and we will get started. Okay, so there's the title, yeehaw. Okay, so our goals for today, we really want to generate interest kind of among the folks who really care about this pipeline towards data-intensive careers. So we're hoping that today will, if you're not already interested in this area, that you become interested in it. And if you are already interested, that you start getting connection with some different folks who also care about this. Want to let people know about some current efforts that we know about in school level data science, and some of the current research about data science, and particularly the AP statistics curriculum and teaching practices that we've been doing this year. And then kind of just provide a glimpse into what data science skills could look like in schools. As we imagine, for many of us, it might have been a long time since you've been in a school setting, and trying to think about what that looks like, or could look like. So I'd like to get started with a little crowdsourcing of an idea here. So if you open up a browser to menti.com and use the code there, I'd like you to enter I think there should be three opportunities to enter words or brief phrases, like 2 or 3 words together that describe the skills and ways of thinking that are used in data science. So I'd like to give everyone a few minutes to do that. And then I'm going to open up my web browser to see what we have to say about that. So I probably caught most of you with, like, you know, taking a sip of coffee or eating your lunch or your breakfast, depending on which time zone you're in. But take a moment and see if you can contribute some ideas to this sentence. And I'm going to take a look. And I think we have about 17 people that have contributed some ideas. So I'm going to give a couple more seconds to see who else may want to do that. And it is menti.com with the code. Let me just put this in the chat. 337261, if you have forgotten it. All right, for time's sake, I'm going to go ahead and share my screen again just so we can move along. We've got about 22 people that have contributed some ideas, and more should come in while we're looking at this. So these are the types of words and phrases that you all have contributed. Of course, with a typical word cloud, it's updating as we're getting new information, and the larger a word, the more it's used. But of course, if we were actually using some of Peter's text analysis software, we might be doing some cleaning, because whenever I see things like data visuals and visualization, I would want to kind of combine those to be the same thing. And so there could be some collapsing going on here, but these are the words that are coming to you also. For example, I also see programming down here and coding up here. I would collapse those into meaning the same thing for the purposes of this. So when you think about, I know we have all probably sat through our probably painful share of presentations when people are giving some kind of Venn diagram of what data science actually is. In many of those diagrams, these types of words appear. And what I think is interesting is that when you think about the words that are appearing here, some of them may appear in those Venn diagrams, like the word statistics. But things like experimental design or asking the right questions, units and calculations, probability reasoning, oftentimes you don't see those things mentioned specifically. So what we're going to be thinking about, I wanted to use that to kind of all get us on kind of a similar page. So one, I think we can see that there's a lot of things that go into data science. And that matters. So let's get back into the presentation. And I just wanted to share this quote. So even though my talk is about thinking about what the kind of experiences we want to give kids to help them think about maybe a data-intensive career pathway, it's also about data literate citizenry. And this quote was written by a statistics educator, and so I have bolded here, you know, as statistics educators, we are challenged to promote understanding of statistics about society. You know, we need to reroute public debate to be based on facts instead of emotions, and to promote evidence-based decisions. And then he pulls out two particular things that I think are situated front and center in data science. The fact that we need our students to think about understanding multivariate phenomena, and to be able to think with and learn from complex data. And this is for everybody, not just for the people who want to be a career that is called data science or something close to that. All right, so again, I'm making an assumption that for many of us here, you may not have been in a middle or high school recently, or you might not know exactly what the curricula standards are that teachers are expected to teach to. So I want to give you some sample standards, and I just bolded, there's a lot on the screen, and this is because I will be sharing the PDF of the presentation afterwards, so that you have this, but I just pulled out a sample of some things. So for example, paying attention to the shape of the distribution, comparing two or more different data sets, accounting for possible effects of extreme data points, representing data on two quantitative variables, fitting a function, assessing the fit, interpreting things, okay? And if we look at some sample next generation science standards, the first three, you see they lead off with analyze and interpret data, and then it's about the particular scientific concepts that they want students to learn about. So things about organisms in our ecosystem, objects in our solar system, thinking about fossils, rocks, continental shapes, seafloor structures. So thinking about earth science. And then in an energy standard here, create a computational model to calculate the change in energy. Again, in energy planning, conduct an investigation. And down here, using mathematical representations to support a claim regarding relationships. So in our science standards, there certainly is some room here, lots of room, and I will talk a little bit more about that later for thinking about data science. Oops, excuse me, we went back too far. All right, so in your English standards, integrating visual information like charts and graphs, follow precisely a complex multi-step procedure when carrying out experiments, taking measurements, or performing technical tasks. That's in our literacy standards. Analyzing how text structures information or ideas. Integrating and evaluating multiple sources such as quantitative data, video, multimedia. And then here's one, evaluating the hypotheses, data analysis and conclusion in science or technical text, and verifying the data when possible. So in our literacy standards, there's opportunities. And some thinking about our social studies standards. Define and frame questions about events in which we live, form hypotheses, use evidence, identify, describe, and evaluate evidence about events using charts and graphs and primary or secondary sources, identifying causes and effects, identify, analyze, and evaluate relationship, distinguish between long-term and immediate causes and multiple effects. So again, if we think about anytime it talks about evaluating evidence or using evidence, that evidence could come from a data investigation, there's opportunities in our social studies standards of ways that we can integrate data science. So what I'm hoping to help us think about together is ways that we can get bigger data in schools. So big data to many of us is not necessarily the big data that we need to have in our middle schools and high schools in order to give students authentic experiences. Some of the pictures that you see here are students dealing with data sets that have, for the middle school kids, these were 6th graders, 7th graders, There's about somewhere between 150, 200 cases, and maybe 16 variables in that data set. High school kids, giving them data sets that have over 1,000 in them, and again, somewhere between 16 and 20 variables. So giving these kids some real experiences to engage in thinking about bigger data. So this slide, I have links to all these different projects, and this is just a sample of things that I could fit on one slide to let people know about some of the efforts that are happening already to bring data science into schools. And I'm not going to go through all of these individually, but I think one thing that's important to think about is that several of them on this list actually are situated in science contexts. I was hinting at that earlier, that many of our science education colleagues are the ones who've been on the forefront of thinking about getting interesting data experiences and computational thinking experiences into our schools. And I think we can look to them for some positive examples. Some efforts that have been happening at the Friday Institute. The Friday Institute for Educational Innovation is at NC State, and I'm a faculty fellow with that institute. And several years ago, we started designing MOOCs for educators. So these are not the Coursera level MOOCs that you have 90,000 people enrolled in. These are MOOCs that are specifically targeted for a very, very small audience of educators around a specific topic or idea that impacts schooling. So I've been the lead on developing two MOOCs, teaching statistics through data investigations and teaching statistics through inferential reasoning. And ironically, I don't know if it's ironic, but interestingly, when we were first designing these courses, one of the team members suggested that data science be in the name of the course title. And I didn't feel at the time in 2015, well, I guess 14 was when we were deciding the name, but I didn't feel that middle school and high school teachers would come to a course that had data science in the name because they don't see that in their standards. And so I really argued that we needed to talk about it in terms of the content that they do see in their curriculum, and that the ways that we can integrate better data investigations in that curriculum. And so there's a lot of data science ideas in those courses, but the term data science is not used strategically. So, and then we also have other MOOCs for educators that have been developed related to computational thinking. And I just have these listed here in a link that when you get this, when you get the PDF, you can take a look at later. So we're really committed to providing quality online professional development for educators to get these kind of newer ideas into classrooms. We know that a lot of teachers teach in isolation, and there's across the US, we have so many rural schools, and the ways that we can impact the professional learning of those educators on the ground is really limited. We just often don't have the capacity. But taking advantage of online learning, we're able to get those educators access to high quality professional development. Another effort that I'm involved in is the project called Esteem, where I'm developing online modules that would be used in undergraduate teacher education to bring better thinking about the preparation of teaching statistics with a slant towards data science. I don't specifically use the term data science, but we are helping the teachers learn to use bigger data and to investigate real world phenomena, and at the same time meet their statistics standards. And so here at RTI, one of the things that we're doing this year is we're developing resources that can introduce data science skills and habits to secondary teachers. We'll have some of those resources more fully developed and completed by the fall. So a lot of the work that we've been doing is aiming towards that, and we're going to give you some glimpses of that today. So some of the ongoing work that we're doing, to move towards this effort is representing the work of data scientists in ways that can help middle and high school students kind of envision themselves in a data-intensive career. So there certainly are some resources out there that career counselors or teachers can use to kind of introduce these data-intensive careers to students. But often number one, there's not enough of them, and then two, oftentimes they use language and approaches that could scare off more students and make them disinterested in such a career than actually help. And so we're trying to think about ways that we can change that. We want to use perspectives of data scientists to inform kind of new definitions of how data scientists actually work and reason, not necessarily just the list of skills that they do, and kind of frameworks that we can use to integrate more data science ways of thinking and skills into the curriculum in secondary schools. Examining opportunities for data science that are actually there in the curricula, and doing outreach to teachers through some of the RTI symposiums that they hold here locally in North Carolina, where they bring large groups of teachers together. So we started with thinking about an interview protocol where we wanted to talk with data scientists or folks who work with large data as part of their job. Their title might not be data science. And it's an ongoing study. It's amazing sometimes how long it takes to actually get IRB approval and to actually coordinate schedules with adults who have busy lives. But we've done 5 interviews thus far, but we're also coordinating and using public interviews that are in blogs or articles with data scientists to actually complement the interview data that we're collecting. And some of the things that we're asking them are about the key ways that they work with data, and for really diving into when they're engaged in a project, what they're doing. We ask them how they would explain data science to younger students. The purpose of doing that is to really think about how would data scientists really simplify what they do if they were going to describe their job to, say, an elementary school student or a middle school student or a high school student, and trying to pay attention to the language that data scientists use when they are forced to try to simplify the nature of their work. And then we ask them to, give us some ideas of how to get more data science in schools. And so this is where I'm going to transition it to Peter, and he's going to talk to you about some of the things that we found in talking with these data scientists. So I'm going to stop sharing, and Peter is going to pick it up.
All right, let me unmute and start my video and bring that up. So actually, before I get into what we found, Holly Lynn and I thought it would be interesting to, again, crowdsource some answers to a question that we were asking in the interviews. And so if you'll head back to Menti, hopefully I've given enough time for Holly Lynn to set this up, but there should be a new question there. And that is, what would you tell a middle or high school teacher they should include in their instruction to give students experience with data to be prepared to pursue a data-intensive career? So this is a question that we had asked as a part of the interview protocol. And so next I'm going to go over some answers that we got from data scientists. And after I'm done, Holly Lynn will go over our responses as well. So I'll give everyone 90 seconds here, my nice Google timer. and give you some time to respond to that. And then when I'm done, Holly Lynn will go through those responses.
And we are starting to get our responses in.
All right. All right, I've got about 30 seconds left if you're entering a response. All right, so very, very interested to see what the responses were from the audience. And I'm gonna go through, oh, hopefully this works here. Presentation popped up on the other monitor. There we go. So what did some of the data scientists we asked in the interview, what did they say here? So one person really focused on case studies and how, is everyone able to see this? The Zoom thing is showing that it's on my other screen, so I just want to make sure. Oops. Okay, so one person focused on case studies, actual problems where you're measuring and observing data or sourcing from somewhere where they have to get hands-on and actually understand what the data means. They go through an example.
Peter?
Yes?
Sorry, I hate to interrupt, but what I'm seeing on the screen right now is not the PowerPoint.
Okay.
Yeah, it's the website window, and then the PowerPoint's kind of like this tiny little square in the bottom left.
Okay. Let me fix
So Peter, if you want, I can show them on my screen, and then you can just discuss them if you want.
Let me try this.
There they
Is this
go.
the right thing? Okay.
Yes.
I'll just keep it in this view and not mess it up with presenter view. So case studies here. So this response really gets at a quote that I've heard DJ Patil attributed to him. So he was the first chief data scientist, and he was fond of saying, remember that there's a person behind every data point. And so this first quote really gets at understanding, when you have a data analysis problem, understanding what is sometimes technically called the data generation process. So where does this data come from, and what's the story behind how we get to a data set? So that's one piece. The second answer here is moving more towards visualization. So if you had a clean data set and you're not asking them to do any kind of boring, intensive work, you can have them do visualization or something they could be interested in and do a coding task of data visualization. So the communication and visualization aspect, another response here. So this one was interesting, basically saying don't do standardized testing, or standardized testing is kind of the opposite of the mentality or problem-solving approach that we take in data science. So when you kind of standardize things, you remove them from what we actually do a lot of times in data science. So this person said do more open-ended project-type approaches or project-type assignments that encourage students to find their own way and come up with their own solutions. Another response was, again, getting more towards gathering their data and understand what algorithm they use and what assumptions they make about the data and finding the most salient features. So again, getting back to understanding what we call the data generation process, or what's the story behind how the data got here and what impact that has towards data quality. And then the final response here I feel like general computer programming is an easy thing to be taught. The concept of statistics is important. To get some of those basic concepts, how you might not know what one person is going to do, but if you've got more people, you can predict what a few of them are going to do. A few of them are going to do this, a few of them are going to do that, and getting them comfortable with understanding trends and population estimates. And then they kind of get into a different aspect, which is a little more interesting, and they talk about developing resilience and getting them comfortable with the scientific method of just chipping away at a problem. So this is interesting that this person talked about more of the affective, kind of holistic approach to what do you do when you get kind of stuck on a problem, and how do we facilitate things like the growth mindset versus the fixed mindset in data science. And so with some of these answers, I think what really comes out to me, we only have 5, but these 5 answers talk about very different things. So what is the implication here for data science and how we might build a data science curriculum? And before I answer that question, I want to bring up a recent article I just read, and it might have been popping up when I was accidentally sharing the wrong part of my screen, but there's this great article by Jason Goodman, who's a data scientist at Airbnb, and his article was 12 things I'd wish I'd known before starting as a data scientist. And I think all of his points really speak to this idea that data science is really broad and really hard to define. So 4 of his points were: 1, data science is a broad term, so treat it accordingly. 2, imposter syndrome is a normal part of the job. So again, we're getting at that kind of affective part of this, of people. If you're not familiar with imposter syndrome, it's just kind of the idea that you feel like you're failing, but really you might have that feeling because you are only seeing the successes of everyone around you, so you don't really feel like you belong. So there's a huge affective component of that. Another one of his points was you'll never have to know all of the tools, right? So there's a lot of tools. And his final point was the most important skill is critical thinking. So what's the connection to education there with all of that? And I'm going to do something that I haven't done in a while and put on my teacher hat. I forgot to mention, as part of my background, I forgot to give this in my bio to Stephanie, but before I was a data scientist, I was a high school math teacher, and I taught for 2 years in an online charter school. And so my whole undergraduate degree was in teaching mathematics. And one of the models that we learn about in educational psychology is something called Bloom's taxonomy. And the idea here is that there are kind of several different levels of learning and how you can assess learning. And I would submit that in order to be an effective data scientist, you have to be working at all of the levels of this taxonomy. And so we saw in those responses, some of the people were focused on kind of these lower level skills of, can we apply programming to build a data visualization? Can we understand what algorithms we might use? Whereas other times people were talking about evaluating, like, how do we evaluate the quality of this data set, and how do we evaluate whether this is a successful or fruitful data collection methodology? And create is a huge part of this. A lot of what you're doing is creating interesting and unique solutions to data science problems. And so because data science is kind of this broadly defined field, and there's a lot that goes into it, and I don't think we will ever settle on one kind of solid definition of this is a data scientist, and these are the exact skills you will need to have. I think it's important to think about, as we're teaching data science, can we get to all of the levels of the taxonomy? Because I think as you evolve as a data scientist, you end up doing more and more of the stuff at the top, whereas when you're just starting, you're kind of just applying algorithms or applying code and not really getting at some of these higher order thinking skills is the lingo we use in education. So that to me is the big connection to thinking about how do we build curriculum and understand successful ways of educating students and getting them to these higher order thinking skills in order to be a successful data scientist. Mm-hmm. So with that, I'm going to pass it back to Holly Lynn, and she's going to go over your responses to this question.
All right. Thank you, Peter. And we're gonna, I'm sure we've all heard the phrase lightning talk, where we're gonna start going on lightning speed to try to get through some of the things we need to talk about. But if you take a look here, I just want to just scroll through and opportunities to look at real examples and real data come up over and over and over again, as well as programming, coding, using different kind of technologies, making it interdisciplinary. Math and science are very important to the other and should be more integrated than it tends to be. All right. So this idea of interdisciplinary. So I think, just as Peter was talking about, is as diverse as our 5 data scientists kind of gave answers, we see a diversity in the answers that we're seeing here as well, all of which are appropriate. I mean, these are the kinds of experiences that I think we all agree would help our students. So let me tell you about a closer look of what we've been doing, taking a look at the AP Statistics curriculum. So I am a professor of mathematics and statistics education, so I work primarily with those that are preparing to be middle and high school mathematics teachers. And statistics ends up being taught by those trained as math teachers. And so many of us would hypothesize that statistics might be a good place for students to learn at least some of the initial ideas related to data science, also maybe in an AP computer science course. Okay, so thinking about statistics and computer science as those big kind of sections of the typical kind of Venn diagram, we think, oh, well then, there might be some opportunities to learn some data science-y stuff in there. So we did a survey. So first of all, just taking a look at this graph, the AP statistics exam continues to really climb. And there are lots and lots of students who are engaged in that course and who are taking, there's more students engaged in the course who actually even take the exam. So there's a large audience there. And we did a survey of current AP statistics teachers this past fall, and we're again still working on some of the data analysis, but I wanted to share some things related to this. So I hypothesize that many of you might think about using real data or bigger data in schools, and that those are important. So one of the questions on our survey asks about of all the data sets that students see in your AP Stats course, what portion of them meet the following criteria? And if you just draw your attention, so about 60% say that most of the data sets that they use are real world. Okay, but only a few of the data sets are actually collected by students. Contains 100 to 1,000 cases, just a few, right? So there's not a whole lot of largeness there. Contains more than 1,000 cases. You can definitely see the larger shift here, with 35% never seeing something larger than 1,000. And then what about the number of variables or attributes? And again, containing more than 10 variables or attributes. Quite a large responses for none or a few, and containing multiple types of attributes, kind of mixing categorical and quantitative attributes together. Again, not very much. Right? So the intent of this talk is not to share all the results from that AP Stat survey. I just wanted to give a snippet related to size of data. But to tell you also a little bit about a content analysis we're doing of the opportunities to learn some data science ideas in the AP Statistics curriculum. So there are 2 career profiles that were developed by the Oceans of Data Institute, the Big Data Enabled Specialist career profile and a profile called the Data Practitioner. And again, when you get the PDF of the PowerPoints, you'll be able to follow these links to go and see the actual career profile. But the group at ODI had done, had taken the big data enabled specialist career profile and mapped it onto the next generation science standards. And they wrote a really lovely report kind of showing what the next generation science standards seemed to do well as far as providing some opportunities and where there were gaps. So we asked the question, how well does the AP Stats curriculum offer the opportunities? And we wanted to look at both the big data enabled specialist as well as this career profile called a data practitioner. So I'm going to just very, very briefly, top level, without getting too much into the weeds, give you a preview of some of the things that we're finding, okay? So I have the tasks and skills of these career profiles summarized at a very high level, top level. There were 7 large tasks for the big data enabled specialist, and then 6 tasks for the data practitioner. And you'll notice that task number 7 and task number 6 are the same, engaging in professional development. So for the purposes of our coding with the curriculum, we removed those tasks because we feel like high school kids are just, I mean, professional development is their schooling. So we didn't necessarily expect to find things related to that. So we took those away, and then we used all the other different skills. So you can see, for example, in Wrangell's data, that there's skills that are listed and they're numbered in the profile 2A through 2N. So that's a good list of skills of how one wrangles data. And over here in transforms the data for the data practitioner, there are a list of several skills. So again, I'm not going to get into the weeds with this, but I just wanted to share with you some of our preliminary findings of what we found. So things that were well represented in the AP statistics curriculum at the skill level. We found 3 skills that were well represented in the big data enabled specialist as well as in the data practitioner. And they fell in the tasks that are highlighted here. They fell within either wrangling data or analyzing data or sourcing the data or analyzing the data. All right, 3 skills. All right, and we counted well represented that we found mentions of these things. And we were very generous in our inferences of there's a good possibility that this is what they mean here, all right, without using the same language. We used that it had to appear more than 5 times within the AP Statistics Curriculum Guide for us to say it was well represented. All right, there would be multiple opportunities for people to kind of experience that. Things that were sparsely there, so it appeared at least once, 1 through 5 times. There were 17 skills in the big data enabled specialist and 16 in data practitioner. But what was absent? All right, there were 49 skills completely absent and 35 skills in the data practitioner. All right, I bolded the tasks that had the absolute most things missing: managing data resources and communicating findings, as well as transforming the data or closing the project, which has a lot to do with communicating findings. Okay. So I'm going to give you a little bit more detail about a few of the skills in the data practitioner, because they're going to inform some of the things we're going to talk about here in a second. So in initiating the project, it's things about identifying the appropriate data, right? So you have a question, or your client has a question. What are the appropriate data sources and variables that I would need in order to answer that question? Being able to sort under sourcing the data, going through this cleaning data process, which they give an example of identifying outliers and errors. Transforming the data, being able to split the data, deriving new variables from your existing data, changing the structure of your data. And then in analyzing, being able to perform data mining, which Peter and I laugh at that in this career profile, some of these skills seem very specific, like splits data. And then there's things like performing data mining, and Peter made the comment, yeah, I think I took a whole course on that. Equal, I don't think. They're not the same grain size. Separating anomalies, interpreting your results. So keep some of those in mind as we lightning go through this next portion here. So a typical data experience in schools, if you haven't looked at some typical curricula recently, students are often given small data sets, or they're even given a graph. They're not even asked to do anything. They're just given a graph. They often graph data by hand or on a graphing calculator, not in software. Right? And they're taught to think, in the situation here, we have the number of births on a sample of days from 2014 in the US. They're taught to think, oh, I see my box plot here. I have 2 outliers. Those pull my mean down. So I should get rid of them and recompute the mean. Right? And I'm not saying that this happens in every single classroom, but this is a typical experience that you see in both curriculum materials as well as in instruction. And then so they take out the outliers and they recompute the mean, and they report the typical births per day as an average of 12,387. And they're typically not given much opportunity to even think about the context of the data. So yes, real data was used, but they don't ever stop and think about, well, why might there have been 2 days with such low number of births? That's kind of weird, you know. Was there anything special about those days? And if they don't have, if the only variable they've been given is the number of births on that day, then they don't really have any further information that they can go digging with. Okay, so that's one of the places where we need to make changes. So we could imagine questions that could be asked about births per day. So kids always like their birthdays, and there's the classic birthday problem. You know, are birthdays uniformly distributed throughout the year? So instead of doing that classic probability problem, we could approach it from a data perspective. Is every birthday just as likely as any other birthday? Or in the US, are there about the same number of births recorded on every day throughout the year? And then trying to think about what data would we need to actually answer this question. So what I have is data from 2000 to 2014, and we really don't have time for me to actually show you live the kinds of things that kids could do. But because I'm taking for granted that many of you have dealt with larger data sets, maybe not in this particular tool that I'm using, which is called CodeApp, but I like to use tools that allow easy access to some of those data moves. I'm going to call them data moves, which is a term that a lot of people in statistics and data science education are using nowadays, but it really stems from thinking about different ways that you can transform your data, which you remember was one of the skills. All right. So, you know, if I look at all of this data and I separate it for the number of births, and if I did a time series here and colored it by the month, I actually start seeing some patterns that, you know, we tend to have more births happening in some of the months than we do other months. Okay, and if I look at the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Wow, Saturday and Sunday look different than the other days of the week. And what I would have students do is, if we wanted to kind of compare these, we could go into our table. We could restructure the data to make it hierarchical so that we actually regroup the data by year. We could also regroup the data by day of the week. And we could compute a new variable by saying, okay, well, instead of just saying days of the week, let's look and see if, well, if it's Saturday or Sunday, let's recode that as a weekend. And if it's Monday through Friday, let's recode that as a weekday. So they can get into some very simple kind of scripting to create a new variable, all right? And, you know, I also notice here that there are, and I am actually going to go into this file very quickly. You know, you notice that there are, so here's my births. We're going to let those populate there. And if you just plot the births, you'd notice, wow, I have this bimodal distribution, okay? And I'm going to recreate in the different orientation my stacked plots here. And oftentimes in the standards, you may have recall in the statistics standards, there were standards about comparing 2 or more data sets. Well, it's typically 2, but yet we can actually do a little bit better than that. But there are several days that happen on weekdays, births that happen on weekdays that seem to behave like weekends. And I can use a data move about kind of separating out those anomalies. So I'm going to set aside those unselected cases. So I just have my ones that are behaving differently. And if I start, I just want to quickly look through this. Here's a date, the end of May. July 4th, September 4th. 2 days in November, Christmas Day, New Year's Day, a date the end of May, July 4th, beginning of September, and that's on a Monday. And if you start looking at these, and if the pattern doesn't start popping out at the students, it's your holidays. So weekends and holidays seem to act the same. So I'm going to go back into here because we are running out of time. But you know, after students have this really rich experience that doesn't happen at the lightning speed that or surface level that we just did, they can actually go and read some articles about births in the US. They can write a report about their findings and thinking about comparing their data investigation with other sources that they read about. And you know, thinking about what are things that they wonder that they could pursue further. Is the pattern from 2000 to 2014 the same if we looked at things 50 years ago? Maybe, maybe not. What if we examined births in other countries? Right? We were looking at US data. How would we source that data? Where would we get it? What would be a good source to kind of think about? And what variables would we want in that data set? So my ultimate goal, and I suspect many of you would share this goal since you're here today, is to kind of increase the opportunities for learning data science skills and ways of working. But I would like to see it done within existing curricula with easy to use tools. I don't necessarily believe that we should create a new course called Intro to Data Science at the high school level and only a select few students get to take that course. And these are my kind of data design principles of how we can bring data science into schools. Data's got to be real, it's got to be authentic, it needs to be multivariate, large, sometimes messy. We should give them some of those messy experiences. The contexts have to be engaging to the students. And the tools that we use, you know, there is not one size fits all tool, but it should facilitate making data moves in both tabular and graphical form. It should support visualization and linking among different representations. So you saw that I was linking between my data table and my graph. And then tools that allow them to kind of learn and produce simple scripting and coding. The tasks have to have multiple entry points. So, you know, kids can take it where, you know, we call this kind of a low floor, high ceiling. And it provokes curiosity and deep engagement with data, which many of you were saying you would recommend. One last thing, if you have not seen the New York Times, What's Going On in This Graph, it is a fantastic resource, data visualization. I think it's every other week maybe, that they put up a graph with some current, that's linked to kind of a current article or current news trend. And they give some prompts. It typically follows the same types of structure. What do you notice about the graph? What do you wonder? And what might be going on in the graph? And could you write a catchy headline, or maybe, you know, the start of a news article based on what you noticed in the graph? And they are, the New York Times Learning Network is doing a free webinar on March 20th. So I encourage you, if you're interested in that, to check it out. We also have, again, when you get this link, if you'd like to see some real kids in classrooms doing some data science stuff, I have some videos that you could watch. And there is our resource, our contact information. So I'm going to stop sharing, and I can always pull something back up if needed. I do see that there was a question earlier about high school summer programs. So one that immediately comes to mind is one that happens at Carnegie Mellon with their statistics and data science department for kids that are actually coming to the college campus to enroll in some summer classes at CMU, and they have some data experiences that they get them involved in. I do think that through some particular foundation or National Science Foundation funding, that there are some of these out-of-school informal types of camps and summer programs that are popping up. I think we need more of them. Let's see, what are some of the other questions?
Holly Lynn, I can take the second question there, I think,
Okay.
or at least get us started. So there's another question about how to fit the use of technology in the curriculum when bringing data science to middle school and high school, and do we need to use software which can be used without coding, or should coding be taught? So this is a really hard question, because I think the use of technology in schools right now is pretty disparate. So you hear about these programs where, like, Apple will give a school a bunch of iPads, or some foundation will say every student gets a laptop in this school. Meanwhile, like, the AP statistics curriculum still has people punching in numbers and calculating standard deviation on a TI-89 calculator. So I can tell you, as a practicing data scientist, I have not used my TI-89 calculator since I started. So I think it's this larger question of, like, I think it just needs to be, technology needs to be integrated more into every subject, but it can't be this, I feel like a lot of times it's this, we fall for the sales pitch of, oh, if we just give every student an iPad, like, everything will be great. So, like, the high school I went to, like, this just happened for them, and they just got a bunch of iPads, and it's like, but you don't, like, it doesn't stop there. It's like, what are you going to do with this, and how is this going to enable students to learn these skills better? So on top of that, I want to give a good example of how I think that can be done. So in high school, I took a class called computer science, but the first half of the class was just learning how to use Microsoft Excel, because the teacher had thought about how do the principles of entering formulas in spreadsheets relate to how we create variables when we program. And there is a great, mapping of, here's a formula in Excel. Okay, well, now that's just a function in your program. And so I think there are interesting ways to use existing tools and give students skills like that. Microsoft Excel, like, it was in computer science. I wouldn't classify it as, like, super computer science-y, but, like, outside of data science, those Excel skills really help me out. And so I think there are ways to integrate it into classes that already exist. But again, it should be done intelligently and not just as, like, a fad of, okay, we're doing technology now, we're doing it better.
Right. And I would add the, even though we didn't spend a lot of time in the tool CodeApp, that I'm part of a CodeApp is part of the Esteem project. And so Bill Finzer is a co-PI with me, and we really think hard about how we design that software so that it is easy to use. And so it's not a core kind of scripting language in order to produce a graph. It's drag and drop, you know, as you saw. And so the user interface is teaching kids the ways to interact with data that don't necessarily require those scripting and coding skills. Although, you know, I was mentioning creating a new variable that you do have to write a formula for in order to create that new variable. And so you can do both.
I see a question that I have to provide an operational definition of critical thinking. So I will take a stab at that, and then maybe Holly Lynn has a better definition from the educational perspective. So I really bring that up because I think it encompasses a lot of different things, and I think the ultimate skill is learning how to learn and determining what you need to learn in order to accomplish a task. So that to me is, I think in an educational sense, what I meant by critical thinking. And that's a lot of what we do in data science. I don't want to restrict my definition to just critical thinking and problem solving, which is like, okay, how am I going to do this? But critical thinking in a broader sense of what skills am I going to need? And also incorporating some of those affective skills of like, oh, how am I going to communicate this? And how am I going to understand like personal barriers that I have to solving this problem? Mm-hmm. So I don't know that that's a strict definition, if that's what you're looking for. I don't know if you want to take.
Yeah, I just want to extend off of that, is that something you were just saying about kind of pros and cons. I mean, I think critical thinking really also encompasses being able to look at, so you have a situation, you have something that you're supposed to either be solving, a problem that you are approaching, or something that you're trying to evaluate, and you're really you're taking the lens of trying to make sure that you're critiquing an argument that's being made. So does this all kind of flow together? And so you're able to kind of bring a perspective to whatever you're approaching that that brings in aspects of logic, that brings in aspects of making sure that you can kind of think about comparing and contrasting, looking at pros and cons, that you're taking a more global approach to whatever you're trying to tackle. So that's a roundabout answer.
Excellent. So we are at the top of the hour, and there are no more questions currently listed, and no one has raised their hand to, oh, there's another one. I'm gonna let you guys address that. Do you see that one up there?
Well, I think that's what we're trying to come up with. So a powerful motivational phrase to encourage students to think about data science. I mean, I personally like a lot of the efforts that are popping up around using data for social good. That there is power in data, and that you can use data to inform not only your own personal decision making, but to actually help solve problems for the betterment of the world. So. Yeah,
and the kind of the other end of that is that's solving social problems, and I think if people are motivated by more internal things, like data science is just a toolkit you can use. Data is everywhere, right, in your personal life. So like, and it's only becoming more and more common. So like, I wanted to understand what my sleep patterns were. So I got a Fitbit and I downloaded my Fitbit data, and I'm now able to analyze that in a better way than I can do in the app, which is awesome. I've built like these random doodads with like a Raspberry Pi to allow me to track to make sure I was taking my dogs out to the bathroom at the right time so they wouldn't go to the bathroom in my apartment. So like, it's just like a cool creative tool set, and I think the creativity part of it is maybe underutilized, and it's hard to talk about in a standards formal context too, because like creative inherently involves making something new. So like, how do you write a standard that says make something new, right? Like there has to be some rubric to evaluate it. But I think, you know, that could be one way to kind of emphasize, like this just allows you, like programming to me is just having a superpower. Like anything with technology I can do if I spend enough time learning how to do it. So that's what's been motivating to me.
Yeah, I mean, related to, you know, this data is all around. I mean, how many people, you know, have some kind of device, whether it's on their phone or whether it is a, you know, little band that they wear that's tracking their steps and computing calories and things like that. I mean, but if you stand still and jog in place, it doesn't account for anything. Like it doesn't say that you've burned any calories, you know? So like understanding how these kinds of devices actually work and the kind of data that they do to build a model of, you know, calories burned is really important, you know? So anyway, that was just, you know, I take the accelerometer on my cell phone and
change from time.
Whoops, let's go ahead. Is there another question?
So that would directly address the question, is there a change in slope from time point 3?
Stephanie, I think you're muted.
I am, sorry. I was trying to let Asley speak to the question in the chat, but I'm not sure it's working. So, but it's basically a question about whether it would be more helpful to have teaching teams at the high school level with teachers from different subject areas working together to create tasks for students. What are your thoughts on that?
My thoughts are that I think that would be, whether it's team teaching or team planning. I also, you know, similar to the team teaching in middle schools, unfortunately, I see lots of middle schools that don't really do that. But there are some opportunities. Yes, there are some opportunities, and we do need to get out of our disciplinary silos.
I will just second that. I think that having the cross-disciplinary thing is also speaks to the motivation question, because data science is cross-disciplinary. Like there's stuff, natural language processing, it's like all English, right? Like you can do data science in an English class in these subjects where people are kind of usually associate with like humanities subjects, right? Like there's still data in there. It's the issue of getting teachers and students to understand like what is data and what can they do with it. And that's another thing that can be motivating to students.
And I'm putting, it was on, oops, I typed it wrong. It was on the last slide, but I want to put my email address in here. If anyone has a follow-up question that they think of, you can please contact me.
Cool. I threw
Wonderful. It's perfect. Thank you guys so much. It's been a really interesting topic. I mean, I'm a former high school English teacher, so I might be a little bit biased, but you know, I think it's been really interesting. We had a lot of great questions at the end. For those of you who are interested, this webinar will be recorded, and once it's up on the NCDS website in about a week, anybody who registered or who is here today will receive an email that lets you know. So hopefully we can share the conversation further than just this hour that we've had together. And another thing to note for those of you in the audience, you know, NCDS DataBytes has been a data science lunchtime webinar series. It's been going on for a while now, but we are going to do this little mini series of data science education-based webinars. And so Holly Lynn and Peter have kicked that off for us, which we really appreciate. But for about the next 3 months, each of our monthly webinars are going to be related to some aspect of that sort of data science education pipeline, you know, whether it's K-12 or, you know, post-secondary or, you know, even ongoing like learning in the workforce, you know, just trying to get different audiences together to think about how we can have a more data literate society, basically. So, you know, keep in touch with us and check out the website, and we will let you know what is coming up next. For now, thank you, Holly Lynn, thank you, Peter, and everybody who contributed today.
Yeah, cool. Thank you.
All right.
Thank you, everyone.
Have a great day. Bye, guys.
Bye.